So what we're looking at today is Unit 8 on kinetics and equilibrium. Some of the things that we're going to talk about in this unit are going to be kinetics, so moving and motion of things, and equilibrium, so how we establish equilibrium or what equilibrium actually is. So when we're looking at Unit 8, first thing we're going to talk about here is kinetics. When we talk about kinetics, there's a couple different types of kinetics, but really we're going to talk more about chemical kinetics. And when we talk about chemical kinetics, we're talking about the mechanics of a reaction and how it actually physically occurs. So if you look at the structure here, you can see that I have 4 different collisions, and in which only one of the collisions takes place. You can see collision 2, 3, and 4. None of those do actually indeed take place. And what I want you to look at is some different things. So where they're interacting with the molecule, but also the orientation of the two molecules in relationship to one another. So what this is actually talked about or called is kinetics. So it is called collision theory, and based off from this theory, particles must collide, and based off from this collision they cause reaction. Well, how do they collide with one another? They have to have proper orientation, but they also have to have the right amount of energy. In order for this molecule to interact with that molecule, they need to sever this bond, and by severing, they need to have energy in order to break that bond. When we talk about kinetics, also, again, the collision theory says that more collisions in a system, the more likely something's going to happen. So increase your amount of interactions between your molecules, you have a higher probability of them taking place. If there are a high number of collisions in a system, therefore more combinations of molecules will occur, the reaction will go faster, and the rate of the reaction will be higher. So when we talk about rate, we need to think about rate as in something happening over a period of time. So how fast is something happening over an extenuated period of time? That is the focus with the terminology of rate there. So when we look at kinetics, okay, so when we talk about the rate of reactions, we look at how fast a reaction actually takes place. So when we look at that, we need to think about the overall rate. So what we talked about was how fast something happens over time. Well, that something is going to be the chemical reaction. So how fast or my reactants change into my products over a period of time, and that's the rate of the reaction. And you can see in here that we have some things, depending on what type of matter we're dealing with, are things that we can change. So concentration, so the amount of something, therefore increasing the number or occurrence of interactions. We have the pressure, okay, so pressurizing molecules, putting them closer together. As they get closer together, then we know they're going to run into each other more frequently. And then also temperature, which we know actually the definition of temperature being average kinetic energy. So again, going back to that energy aspect. Other things, like I just mentioned, okay, to just formally give you those, we have temperature, surface area, concentration, nature of the reactants and products, and a catalyst. Okay, so in order to change these items here, temperature, okay, increase or decrease. Again, when you decrease temperature, the particles move slower, therefore they have less collisions with less energy, therefore our reaction rate is going to decrease. Just the opposite, and you can see that our reaction will actually increase. Surface area, you're dealing with area for exposure, so where can they run into each other? Okay, so crushing something up increases the surface area because now you have more particles that are exposed, therefore you have a higher rate of reaction. Concentration, again, more particles means more random motion, which means more random collisions, which means that you have an increase in reaction rate. Nature of reactants and products. So this is one that students kind of struggle with a little bit. But the more simple you are as a molecule, so like H2O, instead of something that's more complex like C6H12O6, the simpler you are means that you're more likely to have that correct orientation, which means that you're going to have more effective collisions. Also, same polarities, likes like we talked about in a previous unit. Polar things like polar things, nonpolar things like nonpolar things. So this will also increase your reaction rate. Then the last part here, which we're going to start talking about in this unit and later on in thermodynamics, is a catalyst. Okay, catalyst, if you have one, it lowers the energy required to start your reaction, also known as your reaction energy, and therefore your reaction rate will also increase.